So let's talk about repellents in this video, okay? So here in the whitewater solver, repellents are enabled by default. So what are repellents? If you just go here to the whitewater object and enable the in the guides tab, enable the repellents, okay? Notice that I've changed the color ramp of our particles in order to see them red in the previews. I think this makes me see them better. So now I have enabled my repellents, and they are colored by the white color. The repellent size is 0.1. So now if I play my simulation, you see these white particles here, or white spheres, in the viewport. So those repellents here are just particles that Houdini creates, or just some spheres that Houdini creates in order to get the cellular looking of the foam, and you will get what I mean when you just see the example. But what those repellents do is that they just repel, or they have a repulsive force, or they make a repulsive force between them and the particles of our foam. So this creates the cellular looking of the foam. Actually, the repellents can move and can have different shapes, and this just by the parameters that we will control later in this video. So when they just change their shape and their movement, they change also their repulsive force, and this give us the cellular looking of the foam without and this actually breaks the pattern of the foam shape and makes it looks more circular and cellular in some areas, depending on the values and the shape, the motion of these repellents, and their noise. Okay, so if we just stop the simulation for this moment and see here in the whitewater solver, we have those options here for the repellents. We have the feature size range, and this is the range of the size of these spheres here, or these repellents. They now range from 0.5 to 0.9 in size. We can make them actually smaller and bigger. We can increase the range, something like 5. Okay, so now the largest repellent here will be 5, the smallest one will be 0.5. We can change this to something very big. Actually the size here will not be very reflected in the viewport, because the repellent size in the viewport is just 0.1. So if we just increase this to 1, you will see that the size here is very big. Okay, so this is the size of the repellents. Okay, I don't really know why in the viewport they appear all at the same size. I think this is a problem in my viewport or something, but their size should range from 0.1 to 100. Okay, although this doesn't appear in our viewport. Okay, actually we have also the strength range of the repulsive force they create. Okay, so the least repulsive force a repellent here of these repellents will have is just 10, and the largest one is 15. Actually, we have also the noise range and this pulse frequency, and I will show you a video to get the meaning of these two parameters. So let me show you a video from the masterclass of whitewater from side effects. Okay, so this is the video from side effects. actually here we have different values. We have different repellents here with different values of noise and different values of the pulse parameter. So the less we put in the noise values, the more circular our repellents will be. Okay, so here a noise of 0.2. If you see here, the repellents are somehow or so much circular. If you just increase the noise, their shape differs, and this causes more breaking of our foam pattern and the change or more change in the cellularity pattern. Okay, and the pulse parameter here, if you just see here, a pulse of 0.5 causes our repellent shape to change by time. Okay, so here if the pulse is 0.5, the pulse parameter here will change, or the shape of the repellent will change slower than that if the pulse is 1. So here the negative value changes it in the negative direction. So a pulse of negative 0.5 and 0.5 are the same but in different directions, but a pulse of 1 and negative 1 is just stronger change by time. Okay, so this is the pulse parameter and the noise parameter. And actually we have these two parameters here. We have a range of noise from 0 to 1. We can increase this or decrease this. Actually, I encourage you to do more wedges and try different values of the noise, because I have only tried the strength range, and here is the frequency range, and this is how much the shape of the repellents change by time. Actually, you can get a direction here. If you just set this to 1, and it will change in the direction, or in the positive direction, and if you set this to negative, it should change in the opposite direction. Okay, and actually you can use these ramps in order to control the repulsive force by depth and by acceleration, by speed, and actually you can add a seed in order to change the shape of repellents. The seed just changes the shape. Okay, and if you change this number, you may get different results. And this is something like randomness. Okay, you just change a random value here, or the seed value, which is called the random value, to get different shapes. Okay, actually I will give you some examples of different values of the strength range. Okay, so let me show you some examples. So I'll give you 2 examples in order for you to see the meaning of cellularity. Okay, so this guy here is from, I think, 0.5 to 1.5, and the this downward one is just from 10 to 25 strength range. So this strength range here is set to 1.5 to 2.5, from 0.5 to 1.5, and here is from 15 to 25, which is a very different, which is a very difference in the two values. Okay, from 0.5 to 10, this is a lot. It's just 10 times this value. So if we see here the cellular locking, if we just change the frame, the cellular locking is just these circles here that resembles the natural locking of foam and the realism. So in realistic motions of water, we have sort of cellularity between different areas, and we have different circles. So you can change the cellular locking here by different noise values and strength range values. Okay, this is the definition of repulsive forces and repulsions, and actually I find them the most important thing in the looking of foam simulation, especially if it's a scene like this, something moving in water like a ship or a boat. Okay, it will make a cellular foam looking. Okay, actually our simulation is something like a crash of a plane, and cellular lookings will not be very visible, but this is very handy and useful, and you can use it a lot in order to get different looking. And actually I always encourage you to do your own widgets and your own tests in order to get the sense of the parameters, and you just get used to how to use them. Okay, so this is for this video. Thank you for watching.